Hi, everybody. My name is Patrick Chanezon, and this is David Makogon. So I'm from Docker, and he's from Microsoft.
Yep.
And today we're going to talk about how to deploy Neo4j with Docker. I'll focus on the development side, on your local machine, and eventually in Azure, using Docker Machine and Docker Compose. And David will focus on the production side when you want to use Neo4j in production in Azure with the Azure Resource Manager that gives you a lot of control. Yep. Before we get started, so I'm, as you can hear from my accent, I'm French, but I've been in San Francisco for 10 years. I'm a software plumber. I've been working at lots of companies. First 10 years, Netscape, AOL, and Sun building platforms. Next 10 years at Google, VMware, and Microsoft evangelizing platforms. And then that's where I met David. And then 6 months ago, I joined a little company called Docker that's building a super interesting platform. And so that's what we're going to talk about today. David?
Yeah, hi, I'm David. Work for Microsoft. I do not speak French. So, sorry, we're going to have to stay with English
You don't know what you're missing.
No, I think I do. I listened to you talk before. So I do a lot of work at Microsoft with, I'm partner-facing, work in the developer experience team, and I've spent a ton of time in the past few years doing data-related deployments to the cloud. So I'm working with all sorts of NoSQL databases. That includes, of course, Neo4j. I don't want to put my entire career on the slide. I just make a lot of puns, so if I make some today, I apologize in advance, except for the folks that didn't bring me coffee.
Ouch. Okay, before we get started, I'd like to know a little bit more about you and your experience. So first, who here has used Docker? Okay, so that's good. I'll go through some introductory stuff and then through some more hardcore Docker topics. In terms of developer population, so who here is working in Java mainly? Okay, a good crowd of Java developers. Ruby? Node? Hey, Monica, I knew you were there. Okay, very good. .NET? Great, very good. Yeah, I should raise my hand as well, but I'm more a Java guy, I'm sorry. First, I wanted to talk about why I think Docker is important and why I think this talk, I hope you'll get a lot of value from it. When I started playing with Docker a year and a half ago while I was at Microsoft, I had the same kind of aha moment that I had in '95 when I started playing with a web browser. And at that time, I was building client-server applications. And when I used the web browser for the first time, I realized, hey, if we just put some CGI on the server side, we can build applications in a really different way. And then I joined Netscape, and I spent the next 20 years of my career building that kind of web applications. When I started using Docker a year and a half ago, I had the same aha moment thinking, this is going to affect profoundly the way we're building apps, and especially on the development side of the house. So I don't know if you know about that, but today is a very important date. We're October 21st, 2015. That's when Marty McFly in Back to the Future 2 is coming today, so he should be there somewhere. I don't know where the movie happens. It should be there somewhere. That affects an important theme in this presentation to me. I love this quote by William Gibson. The future is already here. It's just not evenly distributed. Throughout my career, I tried to go to companies where the future was already there, whether it was at Netscape or Google, and right now at Docker. And so today, unfortunately, not like in the movie, we don't have these flying skateboards, but at least we have Docker for developing our applications more productively and faster. So Docker's mission is to build tools of mass innovation. What we mean by that is that there are lots of creative people out there, and one of the ways they can be creative is through programming. And then on the other side, you have the internet. And when you're programming for the internet, there are lots of silos. And what we're trying to do at Docker is to build that internet software layer that allows you to program the internet across silos. That's a slide I used to present to my team with David 2 years ago while I was at Microsoft, and I think it just shows why Docker has been successful. What we're seeing right now in the cloud market is that there are the three big players, Amazon, Google, and Microsoft, who are the big players in the public cloud market. And so they're mainly talking to developers. They get adoption through developers. And then on the other side, on the left side, you have private clouds with VMware, Microsoft a little bit as well. And they're talking mainly to the ops teams, and they're talking about private cloud. So VMware is trying to get into the public cloud market with vCloud Air. And then Microsoft has a really strong hybrid strategy with Azure and Azure Pack that you can install behind the firewall. So it's in that competitive context that I think the success of Docker can be well understood. In that context, where I use a metaphor of movies for talking about the various players, and this is a very subjective judgment. So for me, VMware is like 300. They're shouting Sparta, they're super courageous, they have great technology, but we all know how the movie ends. And I used to be at VMware, so and I thought with Cloud Foundry we were trying to get up stack, and now that adventure is continued at Pivotal. On the Amazon side, and that's more a Microsoft perspective, it's like that movie Pacific Rim, where you had this extraterrestrial monsters that are coming from different dimensions. Here, the book industry. They're coming through that fault at the bottom of the Pacific Ocean, and they invade the enterprise market. And the goal at Microsoft was to send them back there. So that's Amazon. They have a mainly public cloud strategy. Then Google, so I used to work at Google, and when I was in the App Engine team, my role was to go out to enterprise customers and just try to pitch them Google App Engine for Business, like that public pass-only option. There's nothing you can install behind the firewall, and we were telling them just go pass right away, and that was like 7 years ago. And naturally, they all laughed at me, and they just didn't want that. And so I really felt like Marty in Back to the Future when he goes back to the 50s and he starts playing rock and roll, and they like it because they're just discovering rock and roll. But when he starts to play hard rock, like the room is silent. They just don't understand that music that's from the future. And to me, one of the issues with Google is that they don't have a transition plan. They don't provide enterprises the transition plan that goes through hybrid clouds. Microsoft, I think, is filled of dreams, like build it and they will come. They build on the public cloud side, huge investments in Azure, and then the private side as well. And then when Docker arrived there, 2 years ago, they kind of changed the whole landscape. And while enterprises were adopting cloud, they wanted a portable approach, and that's what Docker provides, as well as something that lets them do DevOps and that doesn't provide lock-in. So what happened over the past 2 years is that the whole industry reorganized around Docker. And so to me, the new stack looks something like this. At the bottom, you have the equivalent of the hardware, which are cloud providers, so Amazon, Google, Microsoft. On top of that, you have operating systems, and all of them shrunk. So it started with CoreOS, starting to build a small distribution of Linux that just has Docker and a few utilities for managing clusters. Very quickly, Red Hat followed suit with Project Atomic, Ubuntu with Ubuntu Core, and VMware with Photon. The most interesting to me is Rancher, where they have even system services are running in a privileged Docker service. So they have system Docker and userland Docker. On top of that, you have Docker. Then there's a whole ecosystem of plugins like Weave for networking or Cluster HQ for volumes. And the big fight is on the right there, on the top right. It's for orchestration. Once you try to put containers in production, you need to orchestrate them, and there are lots of options out there. The main three are Docker Swarm, Mesos, and Kubernetes from Google. DES is an interesting entrant. It's like Heroku that you can install behind the firewall, and it's open source. Cloud Foundry is reinventing itself with Project Lattice as a Docker orchestration engine. IBM has that Bluemix platform that is Cloud Foundry plus some Docker services. And then there's Tutum. And one of the big news that was announced this morning is that Docker acquired Tutum. So Tutum is a software as a service platform for orchestrating your container. You can bring your own VMs that come from different clouds or from behind the firewall, and they join Docker today. So what is Docker based on? Isolation is based on Linux kernel features, namespaces, and C groups. There's also one of the things that made it successful is the image layer systems. That allows you to cache layers for the images that you're creating. And Docker's mission is to build, ship, and run applications, any applications anywhere. So when you're a developer, you're using Docker, and for your application, you're creating what is called a Docker file. It's a simple declarative format where you can inherit from an existing image. So here, I'm building a Java application and inherit from Java 7. Then I copy my code in there. And then I run javac, I compile my code, and the command is running main in there. So I can do a Docker build with that image, and once I've done that, I can run it in the daemon. Applications that are based on microservices, very often you have lots of different services. For example, your Java frontend, and then a Neo4j database. So for that, you can use Docker Compose. That's another declarative format in YAML that lets you specify all the containers that you want to run. And once you've done that, you go in the directory where it is, and you can say Docker Compose up, and it will spin out all the containers, spin them up, and show you the logs of what's happening. It's very convenient for development. Docker Machine allows you to provision VMs in any cloud and any virtualization platform that have the Docker daemon installed. I'll show you how that works on Azure. Kitematic is a UI. So when I presented Docker at Microsoft, initially all my colleagues were asking me, where's the UI for that? I don't want to be on the command line. So David is not in that camp, but I remember some of my colleagues were not used to using command line. So now we have that tool that's called Kitematic that works on Mac and Windows, where you can create containers and manage them in your UI. So that was on the build side, what a developer is using to build their application. Now on the ship side, we have Docker Hub. This is where all the images live. And one of the announcements at the keynote this morning is that now there is a Neo4j official image, and I'll show you how to use that. So Docker Hub is where ops and devs are collaborating together. We have Docker Trusted Registry, so that's one part of our business model. We're selling Docker Trusted Registry. That's a registry that's integrated with LDAP and with enterprise features that you can install behind the firewall to manage your projects. And then there's the run part. So on the run side, there are a bunch of plugins for orchestration. So we have a plugin for Swarm that talks to Mesos. For volumes, there are 5 or 6 of them. For networking, we have virtual networking enabled in Docker. But we also have like 6 different plugins for that. And service discovery is pluggable as well. In orchestration, the player for Docker is Swarm. When you're using Docker, you talk to one Docker engine from your client. With Swarm, what you do is that you put a daemon in front of all your Docker engines in your cluster, and then you talk the same API from your client to Docker Swarm, and Docker Swarm is going to put your workloads wherever there is some room, based on some constraints that you can pass through environment variables. And recently, Swarm, we made some tests where it scales to 1,000 nodes, and we kind of maxed out on our EC2 allowance. So we asked them for 10,000 nodes to see how far it can go. One other thing we announced at DockerCon last year is Project Orca, which is the run part Project Orca is something that's in private beta right now, and it's run behind the firewall solution that we're going to sell to enterprises for running their containers and operating them. So today, important day, not only Marty is coming, but also Borja and Fernando, and all the team at Tutum, they just decided to join Docker, and we announced that this morning. That's really a big news. It's really a fantastic solution. So Tutum is hosted, but it lets you bring your own nodes from behind the firewall. And they do a build, ship, and run in there. In terms of standards, last summer we announced OCI, the Open Container Initiative. Lots of people in the industry are using containers. We made that a standard. So there's 35 companies who joined that effort to standardize the runtime and bundle format for containers. And the reference implementation of the spec is called runC. So that's something that you can use if you don't want to use Docker or if you want to have complete control on how namespaces are created. What's new in Docker 1.9, the RC is out. And the big news is that we have Docker Network and Volumes, which were in experimental. Now they're part of experimental. Now that they're part of the regular Docker. So everybody can start using them. And these are very powerful features for orchestrating your container. I think it will be very useful to this audience when you want to run Neo4j Enterprise in a cluster. So Docker on Neo4j. So there's a Neo4j official image, lots of documentation in there. To start it simple, you just do a Docker run, -d, to launch it in daemon mode. Then you expose a port. Eventually, you can map a directory on your local machine to the /data directory in the container where the data resides, and then you launch Neo4j, and that will launch just Neo4j, and then you can connect to it. The official Neo4j Docker file is pretty simple. It's just setting a bunch of environment variables, installing some packages, installing Neo4j, and setting up an entry point for it. And one other thing I will demo is how to Dockerize a Neo4j app. That's one of the sample apps in Java. It's a Spring Data application. And so the Docker file for it looks something like that. I just inherit from Java 8. I expose port 8080. I just copy the jar that I have built with Maven into the user source directory. And then I just do a Java -jar with that. That's the beauty of Spring Boot. Once I have that running, I can put that into a compose file. So here I have my compose file, which is using my image that I built there, Chanezon/movie Neo4j. Here I'm going to map port 80 to 8080, so I can go to port 80 in my browser. I'm going to link that to the Neo4j image, and the Neo4j image I'm going to map the drive and expose some ports. And I pass an environment variable that has the link to the Neo4j image in there. That's how the Spring Boot application is going to discover my Neo4j database as well as the credentials. So I'm just going to show you that. Let me get out of there. Oops. Okay, so let's take a look at that. So first, because that takes a little time, I'm just going to provision a Docker machine. So Docker machine lets me provision machines in any cloud. So here I'm going to use Azure. So I say -d Azure, I pass my subscription ID, the type of machine I want. And within, I'm just going to launch that in one of the windows there. And once I've done that, so he's going to crank up for 5 minutes, provision a VM, install Docker in there, create some certificates, set the certificates on my local machine, and then I'll be able to use it. So I've done that before. So when I do a Docker machine ls, I can see all my machines. Actually, one of them is in timeout, but you can see patneo is starting in there. And I can do a Docker machine SSH to patdev, which is the instance that I'm having over there in Azure. And so the credentials are there on my local machine. And if I do a ps-ef, you can see there's Docker daemon running in there. So that's for Docker machine. When I want to run Neo4j, I'm just going to do that. Docker run -detach, the one that I showed you before. So when I do that, it's launching a container. If I do a Docker ps, I can see that I have my Neo4j container running. And if I go in there, in Neo4j, in the browser. So that's the IP address of my Docker machine. You can see that I have my machine set up. And you can see I have data in there. The reason I have data is that yesterday I launched a container. I uploaded the movie database. And because I'm mounting that volume here in $home Neo4j data, it just finds all the data. So you can see I have a bunch of data in there. And the last thing I wanted to show you is how to use Docker Compose. So I'm just going to launch, I'm just going to do a Docker Compose up into that directory. So this is, oops, I have a meeting right now. Sorry, I'm busy. So here is the directory where I have built my image yesterday, and I can do a Docker. Oh, actually, I need to remove Docker stop, because else it's going to restart it. So I'm just going to Docker stop my container. And then I can do a Docker compose up. And once I've done that, you can see that it's starting Neo4j. It's starting the web application. It's showing me all the logs color-coded of both of the containers. And when I go in there and I look at my application, if I go there and I'm mapping port 8080, let's see if it comes up. It may take a little bit. Okay. Yeah, but I mapped so in my compose file, I mapped port 80. Oh, you can see it's coming up. And then I can do a search. And boom, I'm getting the movie data from the movie sample database over there. I could do the same in Azure. I won't show you that because I'm already late and I need to leave the place to David. Just one last thing I wanted to mention before I leave is there's the image includes enterprise version of Neo4j that you can set up with HA, and that's an example of commands you can run to set. So HA on localhost is not very interesting. You will want to start that in a Swarm cluster or to use Docker 1.9, a new networking feature to launch that. Another thing I wanted to send you to is Kenny Bastiani. He's at Pivotal. He's one of the developer advocates there. He has very interesting projects how to use Spark and Neo4j. And I think he gives a talk with Josh Long this evening at the same time as my ex-colleague Ryan Boyd, who invited me here. So I'm in a bind of which one to advise you to go. OK, so David, it's all yours.
Oh, this is good. Did you just destroy me?
Here you go.
All right. So the focus of this piece is, first of all, I just wanted to point out that the original script of Back to the Future, of course, is that they show up at this date to see Neo4j in Docker on Azure at GraphConnect. So that was the official plot, and they're like, no, people won't get that yet. We haven't invented this tech yet, so we'll just make up hoverboards. So. OK, so what is this? Oh, wrong slides, sorry.
Oops.
Which deck is it? OK, here we go. All right, so we've all played with virtual machines, right? Everyone? Yeah, OK. So the whole idea is once you get into the cloud, we're focused on building our virtual machines. We're focusing on building all of our infrastructure, which is typically compute, storage, and networking. So if you take the traditional classic approach, you spin up some VMs, you spin up your storage account, you build out your network. Maybe that has a virtual network. Maybe you've opened up ports to the outside world. Maybe you just want your application to have port 80 and 443 facing the outside world, and then it connects to the database resources and app resources inside that virtual network. So if we've done that, that's a lot of hand-holding. That's a lot of work, maybe a lot of scripting, a lot of linear time progression. So what we introduced in Azure many months ago was something called the Azure Resource Manager. So the idea is you can now take all of your infrastructure and create this single template that describes your infrastructure. You can describe your storage account. You could describe a network interface and a public IP. And then you could define virtual machines. And then you could chain them all together and build dependencies. And once all that's done, whether you have one virtual machine or 1,000, now my account does not support 1,000. But, right, Patrick, can you sponsor that for me? All right, so the idea is you then tell Azure, here's my infrastructure, here's this JSON deployment script, just spin it up for me. And then it's like an atomic operation. Now, on top of that, we're talking about Neo4j, and we're talking about Docker. So the idea is in Azure, what we have on our virtual machines is called virtual machines extensions. All sorts of extensions that we use for monitoring and injecting code into the VMs once they're running. And we happen to have something called a Docker extension. So the idea is you can spin up a VM, and then inside your deployment script, you could say, oh, I would like to activate the Docker extension and inject this Docker file. So if you're jumping ahead in your mind and you're thinking, oh, okay, so I could spin up VMs, I can install the Docker extension, I can pull down the Neo4j Docker file, and everything comes up. That's the idea. So again, we've gone over this. I'm trying to move quick. I know we don't have too much time. But this is a picture of what resources might look like in Azure. So this is something I deployed a little bit before the talk today. And the idea is you tie everything up with a single resource name. So this is I think the name of this one is Hoverboard. I don't know, random name for Marty. So I have a VM, I have a NIC, I have a network security group, which allows me to specify which ports I could have data coming in and out of. I have a public IP address, I have a VNet, and I have a storage account. So all of them are chained together in a single resource group. And then there's dependencies between each one. Now, in order to launch this, I can make a REST API call. I can use one of our language wrappers to launch this. So we have a Java wrapper, we have a .NET wrapper, and a couple of other SDKs. So you can make this management call that says, deploy this entire resource manager script. You could use command line tools. So they're available on Mac, Windows, Linux, and it's just Azure magic happens. I'll show you. And then you can go through the web. So let me show you what that might look like. By the way, this is the portal, and whoops. Let me just, in case anybody's ever done like manual deployment of stuff, right? You pick your virtual machine size. We have machines that run up to 0.5 terabyte of RAM and 32 cores and all sorts of goodness. But you're sitting there picking resources and you're plugging away at it, and it really is not a very efficient way to go. So let me show you what a script might look like. So this is an example of a resource manager script. And if we go up to the top, we have parameters. Like for my script, I'm going to allow the user to dynamically choose a particular region in the world they want to deploy, and maybe I will let them type in an admin username and password for the VM. They can specify the size of the machine. Now, this is just kind of made up, right? You can put anything in these scripts you want. You could put 3 sizes for your organization, small, medium, and large. I mean, it doesn't really matter. But once you have all these parameters, then you'll start defining things like dependencies, right? So here's a particular virtual network. And so my virtual network is dependent on my, network security group. And that has subnets defined, so maybe 10.1.1. something, right? So you basically build this script. Once the VMs come up and running, then we have things like Docker. So now we're saying, oh, okay, in our compute, in our virtual machine, in our extensions, we want to install the Docker extension. And then, once we have that, we're going to hand off some type of Docker image to launch. And in this case, It's the Neo4j image. As Patrick mentioned, I think in the keynote they said this is official. What we were going to tell you today, we had to change script, watch them changing on the fly here. I was going to say that this is like beta, don't really use it in production, but apparently it's production now. All right. So the idea is now you can go and deploy this. So I have this in my repo, so I can say deploy to Azure. And what this will do through the portal is it's going to take this deployment script, and it's going to ask me for all the various parameters that I specified as the script programmer. I said I want you to be able to name your VM name, and I want you to be able to give me a VM size. And so all sorts of parameters I could fill out. I don't know, DLM, GraphConnect, Marty. Right, so there's my storage account, and I can put it in West US, Makogon, right, I can get a password. I can create a GraphConnect. Marty is my DNS name, right? I could choose any size VM I want, and I could choose storage type, so I could use SSD, premium storage, I could use regular storage, doesn't really matter. And once I've specified all that, and I can create a resource group. Remember, this is the name that houses everything, GraphConnect Marty. I can basically agree to the fact that I know that I'm going to be charged a lot of money for this. And then I kick the process off. So at this point, I'm spinning up an entire cluster. Whether that's one virtual machine or three, whether it's a standalone or an HA configuration, whether I've opened up ports to the outside world or I just have nodes talking internally, it really doesn't matter. And that's going to run for a few minutes. One thing that you can also do is you can do this via command line. So we have an Azure command line tool. So let's just say, I don't know, we'll call this McFly. All right, so basically I'm saying, hey, Azure, let's create this new umbrella resource group, and we'll put it in Western US, right? So that's created. And then we can say, oops, let me just grab it from my file here. So now we can say, let's go ahead and create a deployment. And what we're going to do is, I'm saying, resource group, what do we call it, McFly? And then you give it a deployment name. We'll just call it live demo. And what I'm doing is I'm passing a template URI. I'm pointing at my GitHub repo. But you can also say, here's my template file on my disk. It really doesn't matter. So now I need a storage account, DLM, we'll call it McFly. Location, West US. Makogon, let's give it a real fancy password. Right, and DLM, McFly, live. Right, and so the idea is now this is spinning up my deployment via command line. Now if I wanted to look at one that I've launched already, whoops, let me go back to my portal. So if we take a look at, just see where I'm at here. My screen's just a little bit enlarged. There we go. Okay, so let me just switch over to my environment here. So we'll take a look at something that's already been launched. I'll show you the resources. Here's my resource groups. And we'll look for hoverboard. There's my hoverboard resource group. And this will show the exact same resources you saw in my slide before, where I have a VM, I have a NIC, I have a network security group, a public IP address. So if I take a look at the public IP address, I'm assuming you could all see this. So here is the URL that it created for me. Obviously, you can map that to a custom domain name. And if I paste it in and just say port 7474, if all goes well, okay, so I have Neo4j. So I literally spun this up just before I got on stage. I said, I'll just run this script and make sure that the demo evil people don't ruin me. So anyway, this is running in a VM. But what's really interesting is, I mean, it looks like any other VM. What we could do, well, that guy is still spinning up. We can go ahead and, let's exit from there. Okay, so we can do something like we can SSH into the VM we just created. Oops, helps if I know my fancy password. Okay, so I am now SSH'd into the VM that was running earlier. So we could take a look and we can see that there are the Docker logs, right? There's all the processes running. And if we take a look at, let's go ahead and do this. So now I am inside the Docker container itself. Right, I'm just looking around. You can see there's the bin and data directory. So I'm actually taking a look. There's my graph.db. I don't know if you can see that at the bottom. So I'm SSH'd into a VM. I'm connected into the Docker container, taking a look at the exact image that we're taking a look at, that we were looking at in my browser. So that's the idea. Does that make sense? Right, so we have the infrastructure that the cloud takes care of for us. Now we have the Azure Resource Manager that takes all the pieces of the infrastructure, strings them all together, sets up the dependencies, and with an atomic operation, you deploy the entire resource group together. And now we have Docker that gets installed, sitting on top of those virtual machines, and then we inject Neo4j automatically as part of the Docker extension, and when it's all done and spun up, we're left with Neo4j running, and all we did was a simple command line. So, is that pretty cool? Yeah? All right. So anyway. All right, so that is what I wanted to show you. So, Patrick, I was just going to talk a little bit about some of the resources we had to kind of jump in if you wanted to look further. I know there's lots of Docker documentation. Saw a ton of hands earlier that people seem to know Docker pretty well. I'm sure there's a couple of folks that are just ramping up on it. Lots of resources. Patrick has some slides out on SlideShare and some stuff about Azure and Linux. I created a couple of bit.ly links for you for the Azure Resource Manager overview, how to actually create and deploy ARM scripts. And then there's Microsoft Virtual Academy does these things called jumpstarts. So somebody put together about a 30-minute jumpstart video on the Azure Resource Manager. It's definitely worth a watch. And then there was an event called AzureCon a few weeks ago. It was a gigantic live broadcast of all these new Azure features. So if you just search for AzureCon, you'll see all the videos. And there are a lot of sessions, including one on, we made an announcement of the new Azure Container service. So that's in conjunction with Docker and Mesos, and it's the idea of everything we did today, imagine doing it as a service. You could just say, oh, I want to deploy something with Docker. So this facilitates those deployments. And the script I showed you today, that the Docker deploy that I showed you for Neo4j that actually my teammate Jim worked on initially, that shows the basics of how you do it, and then the service takes it the next step. So I think we have, what do we have, like 2 minutes left? We have 2 minutes left. If there's any questions for myself or Patrick before we let you go to the next session, anything? Yes? Is the Resource Manager script Mesos? No, that's Azure's Resource Manager. There's a ton of documentation on how you set up providers for storage and compute and networking. I'll have a link sent out so you could download the sample script that I put out. And there's the Microsoft Azure team put out like a couple of hundred sample scripts for other things as well under Resource Manager. I just wanted to give an example today of how you'd spin up Neo4j with it on top of Docker. The question was overlap between Docker and the Azure Resource Manager.
Yeah.
Azure Resource Manager is about infrastructure. It's about spinning up infrastructure, about managing those dependencies. So you have to create your NIC, you have to create your subnets, now you have your VMs. On top of that, now you can inject software And that's where we hand off to things like Docker.
And I can take this one. There are more details in there where when you're using Docker machine that I showed you, it just provisions a basic VM. You can specify the size and things like that, but there are lots of options that you cannot specify with Docker machine today that you would need for a production installation. For example, deploying on SSD and saying I want a SSD volume mounted for the data, for the graph database for Neo4j. Typically, people are doing either Azure Resource Manager or CloudFormation template for deploying Docker in these environments and setting up all the resources behind it. And then you orchestrate that with Docker Compose and the Docker command line. There are other tools like how is it called? The one from Mitchell Hashimoto. HashiCorp has one tool as well that's pretty good for that kind of stuff. Or people can use Chef and Puppet, or there are a lot Ansible. There are tons of ways to provision infrastructure.
Yep. So I think we're out of time. Thank you very much. Oh, sorry, there's one more if you go real quick.
So the question is there a tax that you're paying when you're mounting Docker volume? And I guess it depends on the volume driver that you're using. So there are several volume drivers out there. Some of them, like Cluster HQ, is based on ZFS behind the scene. So it depends which one you're using. One of the things that's important for hosting databases is to have a good provisioning script that really takes advantage of the infrastructure you have in there. That's why we did this talk together. Because on Azure, you'll want to use ARM for provisioning your VMs and the storage that goes with it. And then you use Docker and the Docker volume to mount these volumes out there. But you need these two steps.
All right, so we could take questions outside. I think
we're out of time. What we'll do is that we'll go just outside, and we'll stay there as long as you have questions. Okay?
Thank you.
Thanks very much.